All right, so we'll go ahead and get started. Um, we're going to be discussing in sort of the second half of this Arctic 21 meeting. Welcome to 2025. Looking ahead to some of the cryosphere science policy events coming in this year of 2025, which is going to be a challenging one. I really want to thank those of you, especially in Washington, D.C., because we're conscious that this is the National Day of Mourning for President Carter. So some of you who would normally be in the office are not. So thank you for logging in despite that. And very, very happy to welcome Dr. Robert Kopp, Bod Kopp, who is also an IPCC author and at Rutgers University. I believe you are on sabbatical this year.
Guggenheim Fellowship leave, but yes.
Exactly. Yeah, yeah. Congratulations on that. Um, and this is to discuss an issue that has been coming up sort of on the margins in many ways, certainly to cryosphere science for quite some time. I'll say, in terms of contexting this for ICCI in particular, in the climate talks and things like the UNFCCC, um, we have been trying over the past several years now to avoid the term tipping points. We tend to use, at the advice of most of you, if not all of you, the term thresholds, because thresholds is a little bit more expressive of what happens in cryosphere. But what we've been seeing over and over again is that the tipping points narrative has really gained quite a foothold, especially among climate negotiators and governments. And we can sort of understand that because they're often in the business of trying to express things in a very simplified way. But at the same time, it always needs to be scientifically correct. And particularly when it comes to cryosphere, talking about tipping points in many ways simply does not fit. And I think in all of the dynamics that are represented by those of you here, you certainly see that. But I also have to admit that from ICCI's point of view, we'd sort of gotten to the point this year of saying, well, if people are going to talk about tipping points, maybe we need to start doing that as well. And then this paper came out just in time to sort of save us from that particular fate, which was most appreciated. If you have not yet read the paper, I can strongly recommend it because it's also in many ways a strong historical document that really delves into the origins of this particular concept. But without any further ado or probably mangling of both the science and the sort of sociological history, I'll turn it over to you, Bob, for your presentation, and then look forward to some active discussion afterwards. So please take it.
Great. Thank you all for being here. I just want to start first of all by honoring President Carter, and then also by asking us all to keep in our hearts our colleagues at JPL. I know at least two members of the NASA Sea Level Change team so far who have lost their homes, and I suspect there will be many more within our community. Um, so with that, I'm going to talk. Um, about tipping points. Has Pam mentioned what I'm going to talk about is covered in a paper that I suspect many of you have seen that came out last month in Nature Climate Change. There's a lot in that paper, including a lot on social tipping points, and for sake of not spending 2 hours on this topic, I'm not going to discover everything there. So I'd encourage you to take a look if you want more. And since you're dialing in today, you probably do. So the key points I want to make to kick off this discussion are a few. Um, One is that the tipping points frame has spread contagiously. And I say contagiously because that's sort of part of the original framing of tipping points from Malcolm Gladwell over the last 2 decades. And I don't think it is ever going to be put in a proper, well-defined technical box. And I actually think if you look at that carefully, it never really has fit in a technical box. The original definition comes from Malcolm Gladwell, and he never properly defined it. And then everything else since has been trying to retcon something to be consistent with that. So the term is best viewed in my mind as an imprecise, boundary spanning term and metaphor. Different groups use it to mean slightly different things. And so you can think of it in that sense as analogous to terms such as sustainability or resilience. So I don't think it is appropriate to use as a technical category. And so I would argue that the key question then is not how to define it, but whether and in what context the term is useful for either communicating our understanding to the general public or to policymakers or others, or for helping us accumulate knowledge across discipline. And I argue, and we argue in our paper, that that key question ought not to be informed, as it largely has been historically, by physical scientists' intuition, but by social science research. And I also think that our default position, has Pam said yours has been, should be one of skepticism, because I actually think we have clear evidence that the term is leading to confusion, and that confusion potentially is something that can be dangerous. So I would argue for continuing to use more precise framings. I think for many of the things, certainly that I think about the most as a C-level researcher, that go on the tipping points label, physical tipping points label, could well be put under the label of unknown likelihood, high impact outcomes or potential surprises. And we should, as scientists, try to adhere to things that capture the salient qualities that the tipping point frames is trying to convey when we might employ it. So that's the argument. To more detail. So if we go in the early history of tipping points, this first appears in the academic literature and work by Morton Grodzins in the 1950s and 60s about racial segregation. This work remains contentious, but the idea from Grodzins and Schellinger is essentially that the racial composition of neighborhoods tipped from from basically all white to majority Black at some point. So it follows a sort of sigmoidal curve driven by societal interactions and network effects. Again, that this is not this is a contended theory to this day, but that's the origins. This is a plot from Google Ingram's of the frequency of the term tipping points in the English language corpus over time. So starting in 1990 here. Climate tipping point and social tipping points are down here for scale. Right, so 1996, Malcolm Gladwell started popularizing the term with a New Yorker article. In 2000, his pop sociology book came out, and that really started this uptick, this tipping point, perhaps, in the use of the term tipping point. And if you ask, well, what was Malcolm Gladwell thinking when he started working on this? He wrote in subsequent reflections. When I heard that phrase for the first time, I remember thinking, wow, what if everything has a tipping point? Wouldn't it be cool to try and look for tipping points in business or social policy or in advertising or any number of other non-medical areas? And so that's where this comes from. And then it started being used in our community. Gabriel Walker, in a Nature news article in 2006, wrote that the idea that passing some hidden threshold will drastically worsen man-made climate change has been around for decades, usually couched in technical terms like nonlinearity. And now it's gained new prominence under a new label. In 2004, 45 newspaper articles mentioned a tipping point in connection with climate change. In the first 5 months of 2006, 234 such articles were published. The idea is spreading like a contagion. In 2005, just before this, I think part of this trend, Jim Hansen started using this in an AGU lecture and in testimony he gave. And in 2008, the seminal work in this field by Tim Linton was published in PNAS. And you can really see this was part of this uptick in the use of the phrase climate tipping point from basically nothing in 2002 to some in 2005 to really a very large increase between 2005 and 2010 or so, plateau a bit, and then another large increase since the Paris Agreement. So that's the history of the term. few questions. So one, we would argue that it's actually, that the term itself is confusing, right? If you use the term tipping point, it implies that there is a point, right? That there is a there is a threshold that can, in theory at least, be identified prospectively. You might not, it might be uncertain. You might not be able to know actually where it is, but it exists. But if that's the case, then you would expect that if you ran history over and over again under the same conditions, you would cross the threshold or not. But we don't see that in climate model simulations, even for the most sort of classically referenced tipping points, the AMOC collapse. So this is a study done by colleagues at GIS, published in 2022. And what they did here was 10 SSP 245, so moderate emissions runs. This is the strength of AMOC, so identical forcing, 10 different ensemble members. And in some of them, AMOC collapses, and in 2 of the 10 AMOC collapses, and 8 of the 10 they don't. So what it's telling you is that there is no threshold expressible in terms of external forcing or global warming level anyways for AMOC collapse. There is no tipping point in this model for AMOC collapse that's expressible in terms of external forcing or in terms of warming level. So it's not a point. There might be a increased risk of tipping with increased forcing, but the point itself doesn't actually describe the behavior of this very classically climate tipping point system. So then they says, well, we're bundling an awful lot of stuff together under this phrase tipping points. So do Earth system tipping points have much in common with another? So if we compare coral reef die-off and West Antarctic ice sheet collapse, both things that often appear in list of tipping points. Well, there's actually high confidence based on assessments like that of McKay and Armstrong that coral reef die-off will happen between 1 and 2 degrees of warming. But it's globally diachronous and strongly affected by non-thermal factors like light, calcite, oxygen, human stressors, and adaptation. West Antarctic ice sheet collapse, of course, is characterized by deep uncertainty. So this is an unknown likelihood, high impact outcome. And there is a centuries to millennial lag between when we might cross the tipping point and the realization. Something different than most people would understand the term tipping point to mean based on worlds like Gladwell. And as I alluded to before, I think most of the things we talk about climate tipping point fall in this deep uncertainty, unknown likelihood, high impact outcome. When our paper was reviewed, there was somebody who said, well, but there are tipping points that are very likely to happen. And they're sort of, right. I mean, the coral reef die-off is a high confidence tipping point. But what do you actually learn by trying to lump these two things together? There is not a lot of commonalities between these two. So we would argue like actually trying to put these in one category doesn't contribute to knowledge accumulation or to communication. But then this term is used even more broadly. If you look at the Global Tipping Points Report term, it lumps Earth system tipping points together with negative social tipping points. So what do we learn by trying to analogize the West Antarctic ice sheet to increases in anomie, polarization, and radicalization? At some level, well, they all involve feedbacks, but life involves feedbacks. Like that just kind of lumping together everything that involves feedbacks, including positive feedbacks, doesn't actually help you very much in terms of understanding. And then there's positive social tipping points. Same argument. Well, what do you actually learn by analogizing West Antarctic ice sheet collapse and technology learning curves? There's not a lot to be gained here in terms of understanding. And then add to this, there are other people who are using the term tipping points in something in a space that has nothing to do with feedback. So adaptation tipping points are actually risk management thresholds. They have nothing to do with feedbacks. And in fact, I think that some of the people who write about adaptation tipping points, like Marlon Hasnud, has, based on urging from people like me, sort of started moving towards terms like adaptation thresholds instead. So if this term is really lumping together a bunch of very disparate things, why are we scientists using the term? Well, this is quite explicit in the early work on this. So Tim Linton's 2008 paper wrote that increasing political demand to define and justify binding temperature targets, as well as societal interest in nonlinear climate changes, motivated their investigation of tipping points and tipping elements. And Linton and Schellnhuber in 2007 wrote that international climate policy needs to induce a socioeconomic tipping to a lower no carbon economy if we are to avoid climate change tipping point results. So from the beginning, uh, the adoption of this term was driven by the policy goals of the climate scientists who first adopted the term, which are broadly policy goals with which I agree, combined with their intuition about effective communication. So we can ask questions, first of all, setting aside the question of whether that's a good way of defining technical terms, let's accept that the goals are good. And this was certainly well-intentioned. So is it likely to be effective? Well, there is actually social science literature on conditions which on situations which make societies more likely to act before a crisis. Rachel Schwam, who's an environmental sociologist at Rutgers, and I wrote a paper on this several years ago. You can see the reference there. Identifying several different theoretical perspectives in various social science disciplines about what makes acting on a crisis, but before a crisis, more, on long-term risk more likely. And what you find is that tipping points do not well align with the potential factors that explain when societies act before a crisis. So from psychology, construal level theory argues that people are more likely to act if they perceive climate change as happening sooner rather than later, if they perceive it as happening in places geographically local, and if they perceive it as having high certainty. Well, tipping points are geographically distant. They're generally off in the future somewhere, and they're generally associated with high uncertainty. So they are not well aligned with things that make people more likely to act in a crisis. Risk society theory argues that societal action on risks is more likely when risks and damages are estimated quantitatively and with certainty. And again, deep uncertainty is an inherent property of most tipping points. And focusing event theory argues that action is more likely when you have a policy community with long-term solutions in place, and then some external event, a focusing event, creates a policy opening. For instance, wildfires or storm-driven flooding, those are potential focusing events. It was clear like what the early adopters of the term were trying to do was to, in a time when there were not as many obvious climate-driven focusing events happening, to use this idea of dramatic changes to the Earth system to create focusing events, but that's not actually something that tipping points are well suited for, right? We are not going to ever have a day the West Antarctic ice sheet collapses that everybody is going to be staring and watching their screens as this happens, the way people might be staring and watching their screens as suburbs of Los Angeles burn. And so I think it's pretty clear at this point that the absence of focusing events is not actually the barrier to adequate climate action. We are being deluged, in some cases literally, with potential focusing events for climate action. And it's the political economy, not the absence of focusing events, that is not leading to climate action commensurate with the scale of the problem. So then we ask, well, can its communicative effects of this metaphor even potentially be harmful? And I would argue yes, because we are seeing and increasingly seeing confusion between a important but arbitrary policy milestone, the 1.5-degree and 2-degree warming levels set out in the Paris Agreement, and physical properties of the Earth system. For instance, UN Secretary General's office has made a statement that average global temperatures have already risen by about 1.1 degrees C. This must have been a couple of years ago, and are likely to reach or surpass the critical 1.5 degrees C tipping point by 2035. In RDC, once past the 1.5 degree tipping point, would precipitate a cascade of devastating effects. So damages, in this view, sort of escalate rapidly right as you cross that 1.5 degree tipping point. And Central Bank of Malaysia, we are on the edge of a climate precipice close to reaching a 1.5 degree C tipping point. And actually, I didn't put this on the slide, but the World Economic Forum had a press release in 2024 emphasizing that 1.5 degrees C is a physical threshold, not a target that can be negotiated. And this is absolutely wrong, right? 1.5 degrees C is a policy target. There is nothing in our understanding of the science to think that 1.55 degrees C is dramatically different than 1.45 degrees C. But if people think that, and we hypothesize that it could lead to a number of potential harms, right? It could lead to a justification of potentially harmful emergency interventions. So I know there are mixed opinions in this group about solar geoengineering. I'm not going to take a position on that, except to say it is certainly wrong to say we need to do solar geoengineering to avoid an arbitrary policy target, right? Staying precisely below 1.50 degrees C does nothing for us. And so if you're going to argue for solar geoengineering, it shouldn't be because 1.5 degrees C is of some special physical significance. It could be because of the escalating harms in general. It can lead to fatalism. Well, we are going to cross 1.5 degrees C, and if this is the threshold that precipitates a cascade of devastating effects, then we are doomed. And that is not actually the nature of the problem, as you all know. And finally, when 1.55 degrees C looks a lot like a marginally worse 1.45 degrees C, it threatens the confidence in the scientific community, even though the scientific community is generally not making these sorts of statements that confuse a policy target with a physical threshold. People think we are. And that I think will can't have the risk of undermining confidence. And note, well, like these are our intuitions and hypotheses. I critiqued some of the founders of the tipping points framing and climate tipping point framing for relying on their intuitions. I think these need to be critically studied. There's some work that supports it, but there needs to be more. And then finally, I want to say that I think many climate tipping points, the things we're concerned about, are less confusingly framed as unknown likelihood, high impact potential surprises. This is a assessment summary chart from Armstrong McKay 2022. And all of the red indicates characteristics that are characterized by low confidence and thus unknown likelihood. And there's a lot of red. And that's actually why the things that are put under the tipping point label are so important to study. They could have substantial impacts. They're not well captured by existing projection tools like global climate models, and we don't need to assess their likelihood. We don't know how to assess their likelihood very well. Like then risk analysis tells you these are therefore important risks to consider. You don't need the tipping points metaphor and its confusing risk for that. And in fact, in the area where we are actually doing things with unknown likelihood, high impact outcomes in adaptation planning, which is sea level rise, we generally aren't talking about tipping points. We're talking about high end outcomes or unknown likelihood, high impact outcomes. AR6 sort of confusingly lumped low likelihood, high impact, and unknown likelihood, high impact together under the term unknown, another term, low likelihood, high impact. And I really think we should separate those out because these are unknown likelihood, high impact, not low likelihood, high impact. But in practice, it's not being used. So there's a lot more in the paper that I'm happy to discuss, but I hope I've at least conveyed some reasons for skepticism and caution about this metaphor. Thanks.
Thank you so much, Bob. This was really interesting. And we'll open it up to questions and comments.